Well, hi, good morning, and thanks so much for coming and joining me here in my shop on the first day of December 2002. And where am I at with this radio now? So, time to change tact, I think. I have two interesting options in front of me here to continue working on this radio, and one is to deal with this meter. Try to make this meter work. That's a signal strength meter. And the other one is to run through the alignment. This would be the first time through, and check to see if the radio is well aligned. It's operating quite well. I'd be surprised if there's a serious alignment problem, but I think I did notice on the broadcast band that one end worked better than the other end, but I'm not sure that's proof of anything at all. Well, you know, I thought about this. I am not ready to pursue this meter. The meter is connected to this cable, which was cut by somebody. It was cut for some reason. I could be totally by accident, but I doubt it. It was cut because something was going wrong, and they thought this would solve their problem. Something was going wrong with the meter, I guess. I don't know. I don't have any good information on this meter arrangement yet. At least I haven't become conscious of it, and so I really got nothing to go on. That's not too good. So I think I'm going to leave this for now, and we'll take a look at the alignment of the radio. It's probably a better next step anyway. The very first thing in alignment of almost any radio is making sure the dial pointer is pointing the right thing at the right time. And there are instructions on that for this radio. Now, part of the instruction is, you know, if it's not correct, how could it not be correct, by the way? But if it was not correct, you have to loosen off a Allen key or Allen screw, I guess you could say, down in here. That's hard to access. It looks like it's doable, but I'd rather not do it. So even if this is out a little bit, I think I may tend to just leave it. Well, let's see how far out it is. The instructions I've already read a bit. It says close the capacitor. I've got the capacitor closed, so we're up at the high end, and then it says look at these lines. So let's take a look at the instructions. That first part, sort of the introduction to the whole alignment process. We'll just read through that and see what it says about checking the dial pointer accuracy. Okay, so here we are. So with the instructions, model S40A, I already know that there's a number of what they call runs of this radio, and exactly which run I have here, I'm not sure. These instructions, I think they list the tubes here. Yes, they do. And it lists an 80 rectifier. But in this radio, this is a later version. The rectifier is a 5Y3. So just keeping in mind that there could be changes in the radio such that, you know, the model I have that makes this table of instructions, this long table of instructions, may be inaccurate somewhere. Probably not, though. It's probably quite fine to use this table and do the work. Okay, alignment instructions. Read carefully before attempting alignment. Yes, that's very good advice. Turn receiver on, allow at least 10 minutes of warm-up. To set dial, turn tuning cap fully. To set dial, comma, turn tuning fully cap fully closed. I'm not reading that right, but I get the idea. I already showed you that. Loosen the dial set screw and set the dial. Here we are. So the last reference line at low frequency end of band number 1 corresponds with the fixed red pointer line. So that's it. So low frequency end of band 1 must line up with the red line. Okay, let's go take a look. To get a good look at this, I'm going to use the close-up camera, which I think is laying on its side on my bench right now. Grab this. Okay, so I was talking about band 1. That's this band down here. I mean, you can see the number 1 right here. 1. It's confusing me holding the camera sideways like this. So, yeah, up here. So let me just make sure the tuning is all the way. You see, it actually goes past the line. Now there's a parallax problem here of some significance, but I'm holding the camera straight on. Well, if you notice, the end lines for each band are slightly different. Not much. Let me put this right on top. And look, no, they're all lined up. Why it picked band 1? Band 1 is actually the least precise place to do this. So sorry about the wandering camera, but I have it sideways in my hand, and my little brain can't calculate. Look at how far out it is, though. So how much is that? So on the lowest band, that would be similar to going, say, from 0.55 to there. I mean, you haven't even made it to 0.54. I mean, really, that's just nothing down here at all. And that's within the parallax area, just, unless you're really carefully lining your eyeball up. What about up at the top now? If I go up to the top band, where are you? Here you are. So here, this amount would be similar to going from, say, 16 megahertz at like 50 kilohertz, I think. I'm not sure, but quite a bit more. Do I really care? Do I really care? Do I really care about that? I think I'm going to say no. And the reason is that we get this guy all lined up perfectly here. It's probably got problems that the alignment is not linear against the scale. By the time you get up here, it's out that kind of amount already. Some of these old radios are pretty bad at this. The linearity of the scale doesn't match the radio anymore. That's been my experience. So you tend to align it very carefully on one frequency or maybe two, and maybe you get it good on those two, but everywhere else it's a little out. So no, I am not going to bother trying to fix this. It's not working. We live in a world now full of digital radios with digital readouts, and if I would really want that, I've got a plethora of digital radios to look at, including a number of SDRs. So, no. And you know what? When you're tuning a radio like this, you don't go, I'm going to tune to 16,840, and then go, okay, 16,840 or 830. That's not what happens. What happens is I'm going to tune to the station that's around here, and then you go fishing for it. That's really what would happen. And generally, you're totally fishing with a radio like this anyway. You're not looking at a book, getting a frequency and a time, and then looking for it. You're just going, hey, what's around here? Oh, listen to that. And the exact frequency actually becomes of lesser importance. So, okay, I justified not fixing this tiny error. How tiny is it again? No, a couple pointer widths. Okay, man alive. I'm just overly picky about this stuff. This is the fun part. The soldering part, the work part's over. Now we're having the fun part. Okay, let's read the rest of the instructions. And I think one of them was turn the radio on for 10 minutes. So why don't I get it turned on? Now I have an option here. I can plug this into my safe, isolated system here. In some cases, that's really not worth doing, because you're going to put a grounded piece of equipment onto the radio, and at that point the radio is grounded. The third prong is virtually there. So I could plug this in the wall, and I'd be doing it with the kind of real power that it would have when I'm normally using it. With this plugged in the wall, I could just, I marked one of the leads there as the hot line, just make sure it goes in that way. But even that is controversial still for me. I still don't know which way is best for this radio. Oh, I just, you know what? Getting too picky again. So I'm just going to plug it into my isolation transformer. And we'll make sure, and it's not on yet, there's no power here. I'll make sure that the grounds I connect are done in such a way that it's not going to cause a problem. And what way would that be? Well, the chassis in this radio is tied to B minus, so I think pretty obviously the negative lead or the ground lead from the signal generator is going to go onto the chassis here. If I had an antenna connected, the same thing's going on. The ground side of the antenna is ultimately connected to the chassis here. And now, what about this meter? So I'm going to be using this meter as the to measure the output on the speaker. I could be measuring the AVC voltage, but I think I'm probably better off following the instructions here. The speaker is isolated in many radios. It has a transformer, and the speaker's on the secondary side, and it's actually isolated away from the radio. So the ground doesn't really matter. You can, say, hook up to the voice coil this way or hook up that way. It really won't matter. But other radios are not like that. One side of the speaker is grounded, even on the other side of the output transformer. In that case, you got to pay some attention to where you're putting the ground here. Bearing in mind you have another ground on from here. They're the same wire. They're shorted together. So you're applying a short between grounds if you're grounding two different things, or connecting the common lead, or whatever word you want to use for it, to two different places. Ooh, ooh, ooh. Stuff can happen. Okay, so did I have to turn this guy on? I never turned him on. Okay, so we're ready to turn him on. Where's he set here? It's set off. I'm going to put it on. They want it on high. I'm going to put it medium to start with. Here we go. Dim bulbs. Dim bulbs are reporting normal operation. Very good. So we're going to let this guy sit here for 10 minutes. When I come back, well, you know what? We'll look at the instructions while it's warming up here. So a buzz has come out of the speaker, just to verify all the nonsense I've been doing the last couple of days. Buzz free. But I don't think this can have any bearing on the alignment, and a little bit of buzzy noise isn't going to throw us off. I don't think. Okay, let's look at the instructions here. Okay, turn sensitivity control to maximum. That's where it is. CW AM switch to AM, except in step 2. Now, I already looked at this. I took a peek at this. What's special about step 2? Step 2 is about adjusting the BFO. So that's a very different process from usual alignment activities you find in radios like this. A radio that has a BFO will have an alignment step for the BFO. Turn sensitivity control to maximum, AM, AVC switch off. Oh, okay, AVC switch. That's right, this radio has a switch for the AVC. Noise limiter off, tone control to high. Noise limiter is off, tone control is on high now. Standby receive switch to receive. Yeah, it's on receive. Band spread dial to 0. I didn't really look at that, but we will in a moment. Volume control should be at maximum position. Output of signal generator should be no more higher than is necessary to obtain an output reading. Okay, that's a standard thing. You usually want radios to be aligned with very, very low signal level. Didn't I find one the other day that you turn the volume up, the alignment point moves a bit with the volume. So you don't normally listen to a radio with the volume turned up full. So on that particular radio, it may have made more sense to do the alignment with the volume turned down a bit. It's a cheap radio. I don't think that kind of thing's going to happen with this one. But I was a little surprised to discover that fact. There was something else about that radio too, which made alignment really, really nutsy. The adjusting the antenna trimmer on the highest band caused the local oscillator to vary. But that's a cheap radio. This is not a cheap radio we've got here. Volume control at maximum position. Well, we may get there. It also means if you do anything, you got a screaming radio on your bench. It's going to yell at you pretty loudly. use an insulated alignment screwdriver for adjusting. 400 hertz modulation signal on all steps except 2, because 2 you're fiddling with the beat frequency oscillator. RMA, I cannot remember what this stands for, but this is a standard dummy antenna that was created by the industry, so when it came time to align radios, you could call for this standard dummy antenna. I don't like the word dummy, I like interface better. Antenna interface to your signal generator. So you have this interface circuit standardized, and here they're describing it. It needs a little diagram to really get a feel for it. I have one of these I built for another radio, so when the time comes I can use that circuit rather, to do this function. And the idea here is, as far as the radio knows, it's hooked up to a typical antenna, not to a low impedance signal generator that I guess will disturb the front end a little bit in some way. So no problem doing that. So right off the bat, a signal generator coupling to high side, this is the signal side of the signal generator output, to the center stator of the tuning cap, low side to the chassis. So they're answering that question for us. The grounded or neutral side, or whatever you want to call it, they call it the low side, was right on the chassis. 455 is the IF frequency. We do this in band 1. We set the radio to center of the band. Not sure that this really has an impact. This should not have an impact. Output, I guess I got to give you some instructions. Output meter across the voice coil of the speaker, that's my intention. And then we're aligning not 2 but 3 IF circuits. This one would be the third, the second, and the first. This would be closest to the antenna, closest to the speaker. Adjust for maximum output in order given and repeat. In a radio like this, where the alignment is okay, the radio is operating, then this is a fairly straightforward, simple procedure to do. In a radio that's way out of alignment, this can become quite challenging. In this case, we're starting with the signal going right through all these transformers to get to the last one. Actually, be this way, here, and then this one. So how can you adjust these if these are so far out of whack there's no signal getting through? That would be tricky. But this radio came out of a factory well aligned, and I don't think it's been monkeyed with, so that's not a problem. We can feed the signal through all these IF stages to get to the first one and still be good. I believe that to be the case. So I'm going to warm up a little more equipment and make this connection to the speaker, and we'll get ready to do this. Okay, actually even before I go drink some coffee here, I thought I'll just take a look at the speaker arrangement and see if there isn't a ground. Sometimes there's a ground on one side of the speaker here. But look what this one's doing. You don't need any of this to make this operate. This wire could be connected here, and there you are. That would be the speaker. That would be the end of it. What's going on? That this wire's coming up here. Okay, it's going through a switch here, and this is how the headphones will pick off its signal. So if you shove the headphone thing in here, it'll push this piece upwards, literally, separate these, and then the headphone will be from ground to the grid of the output tube. So you're not even taking the output of the output tube. For headphones, you're actually back here. And that raises a question about, well, what kind of impedance should these headphones have? Now, these old radios are often made for high impedance headphones, 600 ohms and things like that. Whereas our modern headphones are more like regular speakers, and they might be 8 or 10 or 15 ohms or something. I don't really know for sure. But it might be a bit of a problem plugging regular headphones in here. Don't know that for sure. So, but the headphones are not plugged in, and this switch is closed. So this kind of just goes up and loops around and comes back down. How is this then me putting the voltmeter on here with a power system grounded lead, going to affect the radio. I'd be putting a ground on here. This doesn't look good to me. This does not look good at all. Yeah, I don't like this arrangement for hooking up the kind of meter I was going to hook up. Now, the meter I was going to use, the ground is ground. But the plug on it, if I remember right now, has the third prong cut off of it. So whoever had this meter before me, goodness knows where it was, they cut the ground off. That would suggest they were operating a shop with all the equipment floating and ungrounded. I have to check this out. I don't even know. I think this is a concern. Just hooking up the meter may have unexpected consequences. And what would they be? Well, you'd be putting a ground on the grid here. I don't know. I don't know about what they're saying. Okay, enough of that. Well, let's just check something here. My meter straight here. The pointer's upscale right now, probably because there's just a hum on the line. I haven't hooked the wires up to anything yet. Those wires are going nowhere. So get rid of that reading. Okay, this meter does not have a zero like most meters. This meter is a decibel meter. It's just showing a ratio all the time. So it works a little differently. Just going to put my other meter here on ohmage. I'm going to go here. This is even valid, and touch ground here. Zero. One way or another, this terminal is grounded. This wire's just hanging here, by the way. You're wondering what the heck's going on. That's interesting too. Like I'm just touching the speaker wire. It wouldn't normally happen. But we now know these speaker wires, they're traveling through the phone jack right up to the grid of the output tube. Gosh, that's something new for me. Something new. Well, if I don't want to use this meter, what's the worst thing that can happen? Is the radio will go quiet when I put a ground on. So I have other meters. All of them are basically grounded. Like this one. Yeah, it's a good time for coffee before I do something dumb. Okay, let's experiment a little bit here and just see what happens if we do connect the ground from this meter onto the speaker. My thinking here is the most that can happen, the most bad thing that can happen is the sound will disappear or get knocked way down. Try one side then the other, and we'll see what happens here. It's over here. Oops. No, that's not quite the idea. We got a hum. And if we do the other side, same thing. Exactly the same thing. Okay, so that's got to be some kind of ground loop sort of deal happening. Since these wires we now know go right to the grid of the output tube. Any disturbance on that, we're going to hear it. I can't use this kind of meter. I'm going to have to switch to a digital meter, which I really don't like using. In fact, I really dislike using a digital meter. But we're going to have to because otherwise we're going to be listening to this hum. Now, I've never ever used this meter for this purpose. Jeepers. The lowest setting for alternating current is 6 volts. Well, I don't know what that really is going to amount to. I don't like the way this is going at all. So it's going to lead to having to play a fairly loud volume out of the speaker while I do this work. Okay, so we'll put this on. Oh, even that made a hum. Gee, all this wire the last fellow hooked up to this thing, is this all hum-inducing? It is a little bit. Because again, it's connected back to the grid. You know, I could do away with that connection. I could alter the radio, do away with that connection. That would potentially kill the headphone jack. But the headphone jack here is designed, I think it's designed for high impedance headphones. I don't have that. I would rather have this jack, when you plug in, it just replaces the speaker. And yeah, you know what? That might be a better solution here to what exists. Okay, let's hook up the other side of the meter and see what happens. Okay, so there's a reading. Let's do a little volume check here. That's probably a hum, the hum level we can hear. Hey, let me put that capacitor in place. Look at that. What's this meter doing? This meter's not connected to anything. That's not supposed to even do anything. Wow. Okay, indications are I should solder that capacitor in at this point. I can always unsolder it later. And around and around and around we go. Okay, got the output sorted out. Now, what about the input? So my signal generator should be set to around 455 to start with. 500 or so. Good. Signal level is well, yeah. So this is going to go right on the center capacitor here. This guy here. Luckily, there's a terminal available right there. I'll be able to feed the signal in there. There is a capacitor already sitting here. This is not the RMA dummy antenna interfacial circuit. This is just a capacitor, so in case I run into some DC voltage, it doesn't go back into my signal generator and fry it up. Okay, let's turn the volume up and just listen to the effects. First, what if I put this on the ground? No effect. And I'm going to put this, let's turn this down just a little bit, and then we're going to calibrate. Okay. Put this guy right where it's at. Okay. Didn't change the sound of the radio much. Double check the reading. Turn the volume down, turn it up. Okay, that's good. That's good. Now we're going to swing this into 455. We're going to hear what comes out of the radio here. modulation. Oh, may I have the modulation rate down? No, modulation's at 30%. Let's put 1,000 hertz in there. Maybe I gotta jack this power up a little bit. Because, wow, is that ever weak? Okay, I'm gonna give it another notch up. That's 10 times stronger. There we are. Okay, so we want to tune this to the strongest output. That's why I hate digital meters for doing this. Look at it. What's it doing? So my listening impression, and maybe yours too, matches the reading on the meter here. We're clearly hearing the same thing the meter is reporting. So there we are, 452. That's close. We can't say too much about how well aligned this radio is by doing this particular test. So I'm sitting here wondering, should I sweep this right away, or just continue with the standard approach to alignment? Let's carry on with the standard approach here. If things are way out of whack, we'll know soon enough. Okay, so I'm going to get a suitable screwdriver here. Maybe this guy's going to work. This big plastic guy. Does it fit in there? Yeah. Now, we have 3 transformers to adjust. Which is which? So I'm pretty sure it's closest to the antenna, in the middle, closest to the output. We would start with this one. Are they numbered anywhere? Is there any numbering? No. Maybe there's in a diagram. We'll start with this one. It's not the end of the world if I start with the wrong one. Okay, we're watching the meter now. I want this on 455. This is actually 455 more accurately. My signal counter's a little off, frequency counter. Here we go, watching the meter. Oh, son of a gun. There it goes. Oh, I don't like using these meters. Barely adjusted. Did I go in the wrong one? I went in the wrong one after that little discussion. Let's go down here. Okay, so we're going to try a metal screwdriver, even though it says don't do that. We'll see if it affects it. Not really. Thinking on the metal screwdriver is the highly rigid shaft and the large handle allows precise operation of the screw. That's the advantage. Down. See if I can keep the screwdriver in the slot. It's pretty darn close. So I'm pushing on the radio a little bit here. I can hear it going up and down. Tone-wise, some heterodyne in there I can hear. Okay. This screwdriver keeps camming out, so it's not working well. Let's try this guy. This is really tough to do with this kind of meter. These are so close. Oh, it's quite easy to hear. A little bit of this one. This guy. little more out of it, but generally speaking, it's really pretty accurate right there. The only way to know more would be to put a sweep through it. Why don't we do that? Put a sweep through and take a look at what we get out of this guy. Well, one reason would be I didn't have this on band 1, and I didn't have the dial set in the middle. I overlooked that. And so when I switch bands, wow, what a change in the pitch. Not the pitch, but the volume here. Still picking up stuff. Do what it says. Right spot. Okay. So now we're on band 1. Would this make any difference? I can't imagine how it would. 136 is where we're starting. Screwdriver in. Well, what's your problem, meter? I'm in the middle of using it. There we go. 141 now. We got a touch more. There's a delay in that meter. 45. It is not making any significant difference, of course. This is easy to turn this one. We don't need that up so loud. What? Yes, we do. We can't be changing it. This is the problem with doing this at high volume. And it's not at high volume. Okay, 108. Top. So the rest one's here. Just barely moving these screws. So this radio, for one reason or another, its IF alignment was excellent when I got here. It looks like 13 is the top. Okay, so that made barely any difference to this radio. I'm going to try to set up the sweep, and we'll look at a sweep result. And then we'll call it quits for today after I do that. Good. Okay, you can see on my oscilloscope what I'm getting. I have a sweep going through the IF. The signal going into the radio, same place the other signal generator was connected. I just moved the lead over to the sweep generator. That's this guy here. So the shape on the scope is not reassuring in terms of the test itself. There's a couple things here, which this is sloping upwards. This is sharp and this comes up slow. That's kind of suggesting to me where I've got the scope connected is not doing the trick. I would really want a nice flat here and flat here with a nice dip in between. So making adjustments now on the radio while looking at that, I'm not sure that's a good idea. And I'm not sure we can really derive much at all from that. I'm going to try another method, which is even more difficult to make work. I'm going to give it a try, and that's using the SDR and see what we can find there, because I'm not too happy about this. We'll still keep the sweep going, but try to see it in a different using a different technique here. Okay, so my SDR radio is showing on the screen now. The SDR antenna is this loop of just a long clip lead looped. What we're interested in now is what is going to happen right down in this area, right where 455 is. So I'm going to put the red line there, 455, 455. So the red line is marking 455. Keep your eye there, and what I'm going to do, I'm going to poke this into the radio right near the last IF transformer. So we're just going to poke it right in here. Oh my gosh, look what's come up on the SDR. So it was a strong signal at 455. Now, can I just kind of jam this in here somewhere? So I'm assuming what I'm seeing is the output of that transformer. And am I affecting this radio at all? Am I affecting this radio at all? How would I know that? I gotta stop the sweep. I think that would help. Turn it up. Stick this in here where I want to put it. Just listening. Doesn't seem to. Okay. Go in there and stay in there. Very good. Oh, look at the signal we've got. Wow. Okay, and I've got this fairly well contained to that transformer. I think. Look at the size of it. Now there's another line on the SDR that's over here. This is the local oscillator coming out of the radio, and the rest of this is baloney. This is just baloney nonsense. Look at that. So we're going to expand this. I'm going to zoom in on it. Zoom in on it. There we are. Okay, so right away you see it's centered on 455. It's bang on. Let me tune the radio a little bit, see what happens. So it's overloading my SDR. That's how strong the signal is coming out of here. This is saying everything looks good. That's what this is saying. Let's turn up the, start the sweep going. Volume to do this. Look at that, it's slamming the top. I can't believe it's that strong. It's too strong. Too strong. Okay, well, it's too strong is not going to work for us. I have a smaller coil. Is that going to help? Where is that smaller coil? Where have we gone? Wow, this got pretty warm. Sitting in there. Oh, sitting near this resistor, I bet, is what heated it up. Here's my other loop right here. So same deal, just smaller loop. I'm gonna bet it's just gonna pick it up just as much. Where to go? Oh, I don't have the. Where to go? There it is. That's good. That's good. Okay, stick it in there. This clip lead hanging in the back of a radio is a little scary. Let me do something here. What would I do with this? This is not good. This is not good. Don't do this with the radio turned on. That would be a good idea. Let's try again. Okay, as long as nobody moves, nothing falls. As long as nothing bad happens, nothing bad will happen. There we are, once again. Now we can see the shape. The little thing on the right there is some signal that's being picked up by the radio, this thing here. But it's bang on 455. So I'm going to get rid of the sweep generator. Actually, it's fixed now at one frequency, but it's out of range. Let me turn it right off. Make sure there's nothing going on. Let's listen and watch. Tune around a little bit. Now there's a delay going on, so there's things going in two directions here. There is a delay between the screen and what you hear. It'd be great if I could tune in a real signal. Where am I here? I can't possibly tune in a real signal. There's no antenna on this radio. I have to give it a fake real signal. Okay, fake real signal. Use the signal generator there. That's a fake real. How can you have those two things together? The semi-real signal here. I'm just going to hang wire from the antenna on the back. You know what I'm going to do? I'm going to do it a little different here. Clip onto the antenna input. This might get loud. It didn't make a sound difference. Really? That's kind of strange. What am I doing here? Definitely clipping onto the antenna. Don't understand that problem. This should be making a big... You should hear that. Maybe there's something more wrong with this radio I haven't figured out yet. I'm going to clip one lead from the signal generator. Nothing. Well, I shouldn't expect anything just yet. And the radio is tuned to around between 650 and 7. 650 and 7. What's happening here? I got this on. This is band 1. This is... Oh my gosh, this hasn't been zeroed this whole time. That won't matter though for the alignment I've done. Maybe there's something more wrong with the radio. Again, band 1, 700. 700. What is happening here? There's nothing coming through. Okay, so I already have a ground from the scope right on the radio. I'm going to put another ground on, same onto the chassis too. Nothing bad happens. This should give the signal more strength going into the radio. But this is a strong signal. Something not right. Something's not right here. Let's go up a band. Something not right. We'll have 2 bands, escape the noise. So now we're up right around 7 megahertz. Which you can't quite see there, but we're up, yeah, you can't even see it like that. 7 megahertz. Okay, we'll go for 7 megahertz here. Ooh, we're almost there. Turn it down. Well, okay, so it's a little ways out, but it's there. So I'm going to turn it down some more. Very sensitive radio. So you can see where the scope signal is. It's here. You can see the 2 sidebands on it right there, too. I'm going to tune the radio to it. Whoa! Kind of quick. Now if I close my eyes and tune it, which I've done, my eyes are closed, and I'm going to tune it by how it sounds. I would say that's about it right there. Hey, very good. What are we finding out? We're finding out that the IF is certainly tuned to 455, and we're finding out that everything's working well, and this is a very, very sensitive radio. That's what we're finding out. Very good. I think that's it. So I don't think there's any doubt the IF is aligned properly in here. I'm going to take out this clip lead before it leaps out and falls into the radio. And take off this scope lead. Didn't make any difference. Very good. There we are. Done for today. Oh my gosh, it's way past lunchtime. Jim, what are you doing? Good. Fantastic. This is really a fantastic radio. But what's going on with the broadcast band not responding at all? That's something worth looking into. maybe that's next on the list. Well, thanks a lot for watching today, and we'll see you again tomorrow.